All right, gang, picking up where we started off, pump the brakes a little bit and let's see what we got going on. So we got this Q. We want to sum up our errors. We realize in matrix form that has to be the transpose of E times E. This expands to this expression. Now, um, we ultimately want to take the partial of Q with respect to beta, but beta has two parts, beta 0 and beta 1. Well, we saw that if we just focused on this part alone, that term in the expression, that the partial of beta transpose x beta is just 2x transpose x times beta. Well, you probably know the game plan now, right? The game plan is we really don't need to worry about this because with respect to beta, there's no beta term, so it's going to be 0. So we just need to focus on what this looks like. Well, if you think about it, this beta transpose will be x transpose will be 1, 1. And then our y vector, our response vector is this. So we want to dive in and see what this looks like in terms of matrices, take the partial of it, and see what this collapses to. Well, see what the partial of this is. Same thing we did with this term right here. So let's examine. So we have a 1 by 2, and here we have a 2 by n. So conditions for multiplying are set, so we're going to have a 1 by n matrix. So if we do a linear combination of the first row and first column, I get b0 times 1 plus beta 1 times x1. Second term, again, linear combination of the row and column. And this comes on out to beta 0 plus beta 1 x sub n. Now I can, go ahead and distribute the 2, but I'm just not going to do that just yet. Just going to clutter up things, and trust me, they're going to get cluttered up enough. Now what I have is I have a 1 by n, and of course the response vector is always n by 1. So I'm going to end up with just a 1 by 1 matrix, if you will. So what happens is I take this term, beta 0 plus beta 1x times the first entry in the column. So I'm going to get y1 times beta 0 plus beta 1 x1 plus, and again, this is not like up here where I have different elements of a 1 by n matrix. This is all going to create a 1 by 1 matrix. I'm sorry, an n by 1 right here. This is all just going to collapse to be one matrix. So again, linear combination, y2 times beta 0, beta 1, x1 plus yn times beta 0 plus beta 1 xn, right? Make sure, pump the brakes just a second, make sure I didn't do anything silly. Okay, so this will become -2, and I can see that if I, let's just concentrate on the b0. So I'm going to have y1 times beta 0 plus y2 times beta 0. So I think it's pretty clear to see that this is just beta 0 times the y sub i's, right? Let's get this up where you can see it. Okay, then if I distribute the y sub i's through for this term, it looks like to me I'm just going to get beta 1 times the sum of the x sub I, y sub i's. Now distribute the -2. And I get this. Now, what I want to do next, let me grab a sheet of paper. What I want to do next, again, I got tunnel vision on this right here. I'll tell you what I want to do. I want to have that part handy. All right, so for this, I want to take the partial of with respect to beta. And this is equivalent to taking the partial, please don't make me write that out again, with respect to beta 0, and the partial with respect to beta 1. And it would really, really, really help if you guys could see that, wouldn't it? All right, so with respect to beta 0, all right, this term is just going to become negative 2 summation y sub I. This term doesn't have a beta 0, so the derivative, of course, is equal to 0. With respect to beta 1, the partial is 0. With respect to beta 1, it's negative 2 sum x sub I y sub i's. This is actually an old buddy that we see. I covered, I just sound like the biggest nerd when I said that, didn't I? So this is the sum of the y sub i's, x sub I, y sub i's. And it turns out that this is just one of those three important matrices that we covered, I don't know, a few instructional videos away. It's just X transpose times Y. All right, now what happens? We go back to our original form. I'm not going to rewrite all this. But let's go back to the original. So we know that the partial of Q with respect to beta so this term right here is equal to 0. The partial with respect to beta here is, as we just saw, negative 2 X transpose Y. And we saw in an earlier video that the partial of this term is just equal to 2 X transpose X beta. Now you should know by now that the next step is to set it equal to 0. Set the partial equal to 0. With a little bit of mathematics, well, really not even mathematics, just arithmetic, we can see that we have this. Clearly divide both sides by 2. We're going to multiply both sides by X transpose X inverse. Obvious things happen right there. So drum roll, please. And boys and girls, you need to tattoo that one to the brain. What we can do is we can create our design matrix, take the transpose, multiplied by the design matrix, take the inverse of that, multiplied by the transpose of the design matrix, times the response vector, and in this case our beta will be a 2 by 1 to give us the estimates of our model. All right, let's put it to work. All right, so I've already got the data set that we've seen ad nauseum called triceps. Let's just go ahead and run the model and see what we're supposed to get, just as a checks and balances. So I'm going to predict body fat from triceps. I'm going to look at the summary of the model. All right, so I know that beta 0 is equal to negative 1.496, and beta 1 is equal to 0.857. Right? Yeah, and now I really need to get, so we have 20. I should know that as much as I've seen this data set. Okay, next thing we want to do is let's see matrix operations at work. So I want to first of all create my response vector. So that's super easy to create. So I want that to come from my body fat. I need to know that the number of rows is equal to the number of cases. I know right now that we'll always have one column, and by row equal false. No. Now let's create our design matrix. Well, we know with our design matrix we have to have 20 ones in the first column, so I'm just going to go ahead and create that. There are multiple ways to do this. Just do whatever turns you on. This is the way I do it. Then the X matrix, I'm going to do a C bind of my ones along with, what are we predicting? Independent variables triceps. I know that I need 20 rows, and I know that I need 2 columns. Again, why 2 columns? Well, I have 2 predictors, two estimates, beta 0, beta 1. Actually, I just have 1 predictor, but I have 2 estimates that I'm making. Beta 0, the intercept, and beta 1, the slope. All right, so by row equal false. So I have my matrix X. Now, again, to create my beta matrix, I'm just going to call it B. So the first thing I need to do is take the inverse. So in previous videos, we've seen that we do that with solve. So then I've got to take the transpose of X times X. Then I need to take all that times the transpose of X and take all that, of course, times Y. So when I get my beta, I get my negative 1.496 and 0.857 as I saw that I should get, right? So again, this is an illustration of using matrices, operational matrices, to create our beta estimates. And we just go crazy now. We get into, variance covariance structures, and we get into hat matrix, and you get into prediction. I mean, we're just going to do all sorts of cool stuff once we set the foundation for using matrices, matrix operations in regression. All right, that's all I got.